So somewhere around 7 years, kids start passing these various conservation tasks. They start decentering, and we call that point the entrance to concrete operations. This is the third stage in Piaget's sequence. And it's really characterized simply by shedding all of those limitations from the pre-operational stage. I'm no longer decentered, excuse me, I'm no longer ruled by centration. I think in a decentered way. I can think about something in more than 2 dimensions at once, which means I pass conservation tasks, which means I can reverse things, and I'm no longer egocentric. Uh, the main limitation, however, of the concrete operation stage is I can do all of these mental operations. I can reverse things in my head. I can think about turning something around. I can take someone else's perspective. I can conserve, but I can only do them about concrete things in the real world. And this is why at this age, what we recommend in the classroom is that kids are given lots of concrete ways to manipulate things. Right? I can think about reversing something. I could think about taking another perspective, as long as it's about something that's real in the world. When you ask kids to reason about things that are not true to their experience, they'll just look at you with blank stares, right? If I said, if a elephant is smaller than a mouse, and I try to start from that premise, they say, no, 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 no. That could never be true, right? That doesn't make sense. And they'll always answer about how things really are in the real world. So they can do these mental operations, but they're grounded in the real world and concrete things. It's about recreating, right? If you imagine building a fort, an early childhood kid who's all about pretend play will sit under the dining room table for hours and say, I'm playing in my fort. A concrete operational kid, however, is about recreating in the concrete world what that fort really must look like. So it's going to have windows, it's going to have a door, you get in and out. I might bring cans of food and a can opener because I can't bring canned food if I don't have a can opener. That just wouldn't work. It's about recreating, producing things in the concrete world, and that I can reason about. I can't reason in a hypothetical way, and let me give you an example of a hypothetical reasoning task that you might use to capture this. So suppose you have 4 vials with mystery liquids in them, and they're 4 different colors. And I tell you, some liquid that I've given you, either one vial or some combination of vials, if you mix it with ink, it will turn black ink white. And your job is to figure out which one or combination of these liquids is needed to turn black ink white. I say, what would you do? Take a second and think about it yourself. What would you do to solve that problem? Now, the way that most adults solve this problem is to think systematically. Right? I might think, okay, well, what are all of the possible combinations there are? Right? There would be 4 possible single ones. It might be I would try each one of the 4 vials alone. Then I would try all of the possible combinations of 2, then all the possible combinations of 3, and then one combination of 4. Right? So I would systematically plan all of the ones, and I'd try them each in turn. And if you did that, lo and behold, you'd find out, okay, well, if you mix the blue and the red, that works. And if you mix the green, the blue, and the red, that also works. And so from that data, I could isolate a rule that what's required is that you need to have blue and red, but not yellow, to have the solution that works. Right? I imagined all of the possible solutions, and then I systematically tested each one, and that allowed me to come to a conclusion about a rule. Now, kids in concrete operations won't solve the problem this way because they can't imagine hypothetically about all the possibilities. They would answer the question very concretely. So I might start by trying red and going, oh, that didn't work. Okay, I'm going to add some yellow then, see if it works. Nope, still doesn't work. Okay, I'm going to add some green now. Nope, still doesn't work. Now I'm going to add the blue. Nope, still didn't work. Okay, let me start over from the beginning. Now this time I'm going to start with the green, and then I'll add the red. Let's see what happens. And then I'll add the blue, and lo and behold, it works. And then I'm going to stop. I'm done. right? I solved it by trial and error. And that's going to lead me to a different conclusion than reasoning hypothetically. Now, this distinction about hypothetical reasoning, this is one of the main points that marks the transition from concrete operations to formal operations, traditionally around 11 years. And this is marked by an ability to think abstractly and ability to think hypothetically. Now, we see these new abilities to think abstractly in different ways in many different domains. So in math, for example, when you start doing algebra and start thinking about x and y, even though x and y don't actually mean any concrete number, oh, that requires some abstract thinking, and that's going to be challenging for kids who haven't transitioned to formal operations to really get how algebra works that way. We also see illustrations of abstract thinking in the way that kids think about God. So concrete operators tend to think about God as a person. He's often a very big person, and if you ask them to draw pictures, right, he's often an old person with a beard holding the earth, or somebody who exists in a specific space. Formal operators can think about God as an abstract concept, and so they draw very different representations. So we see this abstract thinking play out in lots of different ways, and we've already talked a little bit about hypothetical reasoning. But the final point that I want to make is, again, remember, this is not some rapid single-day transition from one stage to another. So most kids who transition to formal operations and become good at thinking abstractly in one domain may not necessarily be as good about thinking abstractly in all domains. Think back to your own schooling and think about the subject that was the easiest for you. And that's probably right in high school, right? You loved that subject, you did really well. That's probably the class or the subject matter in which you first started thinking abstractly. It probably came more easily to you in that domain than in others. And so something to remember when working with kids, just because they've demonstrated some elements of abstract thinking doesn't mean they will use it in all domains. Even on everyday life, most adults don't use that sort of systematic thinking that we talked about in the last task for every task that they have. We don't think systematically necessarily when we're at the grocery store about which product to buy. We don't necessarily use that same systematic thinking in all tasks. But Piaget would argue around the age of 11, we all become capable of thinking systematically in that way and thinking abstractly.